All right, good morning. It's Sunday today. I'm recording the lesson for Monday morning or afternoon whenever you do your math work. And yes, I understand some of you guys may be mad because we're doing all 30 problems in just one day. I hope you're not too upset. This is going to be a two-part video. This is part one. I'm going to do the lesson and up to problem number 13. And then in part two, we'll do the rest of them. Guys, I know you guys might be upset and I'm sorry about that, but we're catching up a little on our math. You guys are doing pretty good so far on all of the quizzes and all of the tests. So I just kind of want to keep working ahead, making sure we don't fall behind and make sure we stay ahead. On top of that, this Friday there won't be any classes, okay? So disregard whatever's on the on your program, but I'll talk some more about that later on. All right, right now you should be on page 402, lesson 83. Make sure your book is open. If you need to pause the video to go grab it, go ahead and do that. But I want you to read through the lesson as I read through it, and we'll look at a couple of examples here on the board. So let's go ahead and jump right in. All right, recall that, that the four operations of arithmetic are addition, subtraction, multiplication, and division. When more than one type of operation occurs in the same expression or in the same problem, we perform the operations in the order described, okay? So first of all, perform the operations within parentheses. So if you have a problem with multiple expressions in the problem, okay, or with multiple operations in the problem, you do the ones in parentheses first, and we'll look at it right now. Second, multiply and divide from left to right, okay? So say you have a problem with no parentheses, but you have a multiplication, a division problem, an addition, and a subtraction. Before you solve anything, you need to do the multiplication and division problems first in order from left to right, the same way you read. All right, and then lastly, add and subtract in order from left to right, okay? So let's go ahead and look at some of these examples. We have the problem set up here, 2 times 8 plus 2 times 6, okay? So if you just went in order from left to right without paying attention to the steps that we just said, you would go 2 times 8 plus 2 times 6. So it would be 2 times 8 is 16, plus 2 would be 18, and then you would do 18 times 6, which wouldn't give you the correct answer, okay? Because we're not going in the standard order of operations, okay? So the first thing we need to look at is the different types of operations we have here. We have multiplication and addition, okay? The first operations we need to do are the multiplication operations. So 2 times 8 is 16, then we do 2 times 6 is 12. After we have completed the multiplication operations, we could go to the next operation, which is addition, and we do it from left to right. So we go 16 plus 12 is 28, okay? Another example, we have 0.5 plus 0.5 divided by 0.5 minus 0.5 times 0.5. So here in this problem, in this expression, we have all the operations in one expression, okay? And this is a really good example. That's why it's in the book. All right, so we're working from left to right. We need to multiply and divide from left to right first. So before I add 0.5 to 0.5, I have to divide 0.5 with 0.5, which gives me a 1. So now I have 0.5 plus 1 minus, and before I subtract the 1 from the 0.5, I have to multiply these 0.5s together. So imagine these in parentheses, okay? These are the order of operations. There's no parentheses in these problems, but you know from your rules that if there's no problem with parentheses, okay, and you can't do the problems within parentheses first, or the operations within parentheses first, you have to do the multiplication and division problems first. Okay, so we go ahead and do that. So I went ahead and multiplied them. So now we would have 0.5 plus 1 minus 0.25 to give us the final answer, 1.25. If we go out of this order, we don't get the correct answer that it's supposed to be when we follow the standard operation. Okay. Next we have a problem set in parentheses. Okay. So here we have 2 times 8 plus 6. Okay. Because the parentheses are present, okay, even though this is multiplication, and in this case we would do it first, because we have parentheses, we would perform the operation within parentheses first. So before we multiply 2 times 8 and 6, we need to add 8 and 6 together. So 8 plus 6 is 14. Now we can do the next step, which is multiply the next order of operation. 2 times 14 is 28, okay? Other than that, there's a little calculator test you can do. You can see if your calculator does it in the standard operations. Some calculators are set up to where they do go in standard operations and some don't, okay? So you have to be careful. There's the calculators that aren't, you have to set the parentheses around these operations, okay? But you're not using a calculator for this, I hope, because I don't think you need to, because you guys are so smart. All right, problem number 1. Let's go ahead and figure it out. Go to your books to page 404. We're on problem set 83. Problem number 1. What is the ratio of prime numbers to composite or even numbers, or not even numbers, but numbers with different multiples? What is the ratio of prime numbers to composite numbers in this list? So we have a list 2, 3, 4, 5, 6, 7, 8, 9, and 10, okay? Our composite numbers are numbers with multiple factors. Our prime numbers is a number that with the factor of 1 and the number itself. That's a prime number, okay? So our first prime number is 2, okay? Because the factors of 2 are only 1 and 2. Same thing for 3. 4 is a composite number, so I'm gonna circle it. Okay, 5 is another prime number, so I'm going to underline it. 6 is a composite number. It has factors of 1, 2, 3, and 6, so that's a composite number. 7 is a prime number, okay? 8 is a composite number. 9 is a composite number, and 10 is a composite number, okay? So the ratio is, what is the ratio from prime numbers to composite numbers? So the first information that I'm going to give is prime numbers, okay? So there are 1, 2, 3, 4 prime numbers. So I'm gonna write that as my numerator, and then 1, 2, 3, 4, 5 composite numbers. So that's gonna be my denominator. So this would read 4 to 5. The ratio of prime numbers to composite numbers would be 4 to 5. So make sure you have this written down. Please don't just write this on your paper, 4 to 5. I want you to see how we got that information. Okay, so make sure you have that all written down on, make sure you show your work on all your paper. I apologize. I'm going to do this a couple of times where I'm going to go back into the camera. Oh, no, actually, never mind. That was just checking if I was still recording. All right, problem number 6. Let us solve this problem. We have 6 plus 6 times 6 minus 6 divided by 6, okay? So, naturally, we would probably want to do these first problems, 6 plus 6. But because we know our rules, we know we go to to step number 2, where we take the multiplication and we do that first. Multiplication and division needs to go first. So before I can add 6 to 6, I need to multiply 6 times 6 and divide 6 by 6. So I've got 6 plus 6 times 6 is 36, minus 6 divided by 6, 6 goes into 6 one time evenly. So 6 plus 6 minus 1 is 41. So your final answer would be 41. Now, the final answer is important, but, so yes, show your final answer, but most importantly is solving this, showing your work here. If you need to pause the video, zoom in on that and copy it down, go ahead and do that. You're gonna have problems like that over the next problem sets. All right, let's go on to problem number 3. Let's go on to problem number 5. Write 8% as a reduced fraction. So I went ahead and put the percent into its fraction form, okay? A percent is a fraction with a denominator of 100. But now I need to put it in reduced form. So I see what number goes evenly into both of these. I see that 4 goes evenly into both of them. So I'm going to divide both the numerator and the denominator by 4. 8 divided by 4 is 2. 100 divided by 4 is 25. So your final answer would be 2 over 25. All right, let us go on to the next one, problem number 7. Write 1 over 20 or 1/20th as a decimal number. So we're going to convert a fraction into a decimal. I've already worked out the problem here, but notice how the denominator becomes the divisor, the numerator becomes the dividend. Now I added a decimal and decimal places to hold a value in the tenths place and in the hundredths place, okay? So I've got my 1, this is my numerator, I set up my division box. I see that 20 cannot go into 1, so I write a 0, and then I line up my decimals. Very important. Make sure you place your decimal. We're converting a fraction into a decimal, so your decimal is important. Okay, 20 also does not go into 0, but it will go into 100 5 times. 5 times 20 is 100, subtract it. There's no remainder, so there's no need to keep adding zeros. Your final answer is 0.05. Next, number 9, what is the area of the parallelogram? If you notice the parallelogram, there's 3 measurements there. You have the base, which is 16 centimeters. You have one side that's 25, and you have the height that's 24 centimeters, okay? When looking for the area of the parallelogram, remember that you need to multiply the base, 16 centimeter, times the height, not the side, but times the height, which is 24 centimeters. So I went ahead and multiplied it. Let's go over some long multiplication while we're here. So 6 times 4, whenever we're multiplying, we're gonna do first the numbers that are on top of each other, then we're gonna go across. So first we multiply 6 times 4, that gives us 24. And I raise my 2 over here, that's the 2 that came from the 24. That goes above the 2. Now I do 6 times 2, which is 12, and then I add that 2, which is 14. Next, before I multiply my second number, I have to write a 0. Okay, so I go ahead and have my 0 written down. Then I multiply 1 times 4, which gives me 4. Then 1 times 2, and I don't add that 2 anymore because that's not part of this problem. 1 times 2 is 2. Okay, then I can take these and add them together to give me the final product. So 4 plus 0 is 4, 4 plus 4 is 8, 1 plus 2 is 3. So we have 384. Now, this is the numeric portion of it, but we're also multiplying the units of measurement, which are centimeters. So centimeter times centimeter would be represented, or will be represented, as centimeters squared. So your answer is not correct if you simply wrote 384 centimeters. It has to be 384 centimeters squared. All right, so make sure you have that written down. All right, problem number 11 took up a large portion of the board. We have 3 and 1/8 plus 2 and 1/4 minus 1 and 1/2. All right, so problems within parentheses, the operations within parentheses need to be done first. So before I can subtract this or do anything outside of it, I need to focus on this. So I've got 3 and 1/8 plus 2 and 1/4. So I went ahead and stacked them up like we usually do here in class. So 3 and 1/8 plus 2 and 1/4. In order to add these two fractions together, they need to have a common denominator. Okay, so to find the common denominator, I multiplied 2 over 2. I'm sorry, I need to multiply the denominator by 2 to have a common denominator of 8. We need to have the greatest common, the least common multiple between 4 and 8 is 8. And we've worked through least common multiples on different videos, and also in your handouts whenever we had them here at school. But if you have any questions about finding the least common multiple, leave a comment or give me a text or give me a call. All right, so the least common multiple of 4 and 8 is 8, okay? So in order to convert my denominator 4 into an 8, I need to multiply the denominator by 2. And whatever I do to the denominator, I also will do to the numerator. Okay, so I multiplied 1 over 4 times 2 over 2, which gave me 2 over 8. Now 3 and 1/8 and 2 and 1/8 can be added together. Remember, when adding fractions or subtracting fractions, once they have the common denominator, we only add or subtract the numerators, okay? In this case, we're adding, so 1 plus 2 is 3/8, and then 3 plus 2 is 5. So now we've got this portion. 3 and 1/8 plus 2 and 1/4 equals 5 and 3/8. Now I took my 5 and 3/8, placed it up here, this is the greater number, and now I'm subtracting that by 1 and 1/2. So I've got 5 and 3/8 minus 1 and 1/2. I need to do the same thing here. I need to find the least common multiple between 2 and 8. And again, the least common multiple between 2 and 8 is going to be 8. So to turn my denominator 2 into an 8, I need to multiply it by 4. 4 times 2 is 8. And whatever I do to the denominator, I have to do to the numerator. So 4 over 4 times 1/2 equals 4/8. And because this is already set, I just moved it over. 5 3/8 minus 1 4/8. Okay, and then this is the final part where we solve. We can't take away 4 from 3, so I'm gonna borrow from the 5. If at any point you need to pause the video and rewind it, go ahead and do that. If there's something that is, I'm not explaining well enough for you to understand, feel free to give me a call or shoot me a text. I'll be available. All right, so we're gonna borrow from this 5, gonna make it a 4. We're gonna take our whole number fraction, which will be 8 over 8. Remember, that's based on the common denominator. And I'm gonna add that. So 8 plus 3 is 11. So now we'll have 11 over 8. Now we can subtract it. So 11 minus 4 is 7/8. And then 4 minus 1 is 3. So your final answer to this problem, problem 11, is 3 7/8. All right. Now, the last one for this video, for part 1. We have 8 1/3 divided by 100. Okay, remember when multiplying or dividing fractions and mixed numbers, you need to change the mixed number into an improper fraction. So I went ahead and did that. 3 times 8 is 24, plus 1 is 25. Okay, so I've got 25 over 3. Now, when dividing, I can't divide by 100, so I need to multiply by the reciprocal of 100, okay? So I went ahead and changed my operation from a division sign to a multiplication, and now I'm going to multiply it by its reciprocal, okay? 100, the whole number 100, as a fraction would be written 100 over 1. Its reciprocal is 1 over 100. So I went ahead and, so you can go ahead and multiply it there. But what I did is I went ahead and canceled it out because I know that 25 goes into 100 4 times. So now instead of reducing, I can just cancel it out here. 1 times 1 is 1, 3 times 4 is 12. And that is the final answer to number 13, 112. I feel like I talked really fast in this video. I might do that in all the videos, so I apologize. This is the end of part 1, and let's go on to part number 2 and finish doing the rest of the problems. Thank you.